and I'll hand it over to Matthew for some more details about the specific studies and the work we are doing to support the expansion to risk. Thank you.
Thank you very much, Emmanuel. Confirm, Lauren, if you can see my screen now. All right, perfect. All right, thank you, everyone. So as Manos mentioned, I'm now going to give a brief overview on the Unified Wearables Framework and the progress we've made to date so far, and we hope to be going. So I'm only going to quickly go over the timeline of where we started and where we hope to be in the next few years. So as Manos very nicely pointed out, ProPASS started around 2017 with a strategic decision for thigh placement only, with the first publication from ProPASS around the 100 different devices coming out in around 2020. And then towards the middle to end of 2022, we began having some conversations around possibly expanding ProPASS to the risk placement off the back of some of the very nice research being done to improve the risk methodology. It was from these conversations where we then laid out a series of studies that would incrementally build off of each other. So in 2022, and then going into this year in 2023, we had a series of, we had one main lab study. We had participants wearing both thigh and wrist monitors concurrently together. And we had ground truth measures using gold standards of energy expenditure and intensity through indirect accelerometry and heart rate. And then the next step to build off this is to apply these methods and techniques that we're going to develop into free living environments. And in these free living environments, we obtain our ground truth measures using body worn cameras and heart rate sensors. And the participants, again, will be wearing both monitors on the wrist and thigh concurrently. And then finally, to really encompass that full 24-hour day with wearables, we then have a third study building off these first two that will incorporate more data collection under free living condition and specifically involve at-home free living sleep data using at-home polysomnography kits. Ultimately, by the time these three sequences of studies are completed, we hope that around the time of 2025 or in that frame, we'll be able to incorporate these techniques and harmonization methods into ActivePass, making the full data sets we've collected, as well as the software open source and free for use throughout the research community. So touching on the first study that Manos briefly mentioned in his presentation, we're currently in the process of developing energy expenditure estimation models for the thigh placement to directly address one of the core key concepts of the ProPASS 24-hour dimensions, physical activity intensity estimation. In order to do this, we had participants coming into our laboratory, wearing the monitors and performing a variety of activities that encompass the full energy expenditure continuum. These activities include a variety of things such as sitting, doing household work, running, and stairs that went from sedentary up to vigorous intensity. We know going into this that traditionally in physical activity research with wearables, energy expenditure has been estimated by mapping usually a single feature, usually the magnitude of acceleration or power distribution, I've shown in front of you, entropy, and using some method of a linear or non-linear regression model to predict energy expenditure. However, these prior approaches have all been reported to have substantial or relatively high error rates with the root mean square error all exceeding 1 mep. This then led us to the next question. Are there areas for improvement, and can we do better to build off the research that's already been done? Well, we're very aware that when it comes to activity intensity, there are two main contributors to that. There's body composition and activity type. And then utilizing the wearables, the very rich data from the wearables, we knew that from the thigh placement, we can get very accurate prediction and detection of activity type. Therefore, we decided to utilize this from the wearables to then expand into different types of energy expenditure within the activities. So as you can see in front of you from some of the data, that across the different types of activities we're able to detect, we see that there is no single continuum that connects all the different energy expenditures across the activities. So in other words, there's really no one size fits all approach. So with this in mind, we then use what we have called the two-stage model, where by first identifying the activity type, we can then potentially get more accurate estimation of energy expenditure and therefore intensity by developing regression equation for each individual activity being detected by ProPASS. Ultimately, through this, what we have seen so far is that by first categorizing the activity type, we can greatly improve our intensity classification estimation. Before going any further, it's really important to acknowledge what Manon said is that a lot of the work that we have planned and want to do in the future isn't trying to reinvent the wheel. What we're doing is building off a really strong research foundation that has been laid by others to advance the research with wearables for the community. And although wearables in physical research has been around for roughly 40 years now, it was around 20 to 25 years where it really began taking off in popularity. And this was first notable through a special conference held at the NIH in the US back in 2004 among a series of international researchers, with publications from this conference coming out in 2005 on how best to utilize and maximize the capacity of wearables in our physical activity and health domains. And then a few years later, in 2009, there was a follow-up conference to this held in North Carolina, where the researchers discussed how to make progress on this and advance our methods even further. And one little thing that I find pretty interesting about this with the 2004 conference was at the time, the research community was using heavily the cut point methods as well as proprietary activity counts. And one researcher had stood up during the meeting and asked, why are we using cut points when the computer science engineering fields are using wearables with machine learning techniques and are seeing much improved accuracy estimations? And why are we also using proprietary activity counts instead of the raw data that contains all the rich information? From what I've been told, all the researchers in the room turned to each other and kind of nod their head in agreement saying, yeah, why are we doing this? Why don't we request access to the raw data? I find this interesting because it's really an example of one ripple leading to a wave to what we are now seeing today. And then continuing from this, a really nice example of us at ProPASS building off the research that's been laid down by others is with the two-stage approach. The two-stage approach that we use in ProPASS was really first introduced to the community around 15 years ago, called divide and conquer, and then activity-specific prediction equations as well. So all we're really doing is taking what's been done, the great work that's been done, and building it to improve on it where we can. And the same goes for our goals of harmonization for cross placement, mainly with the wrist and the thigh. There's been a lot of great work that's been laid out on how this can be started and how it can potentially be accomplished. And we plan to hopefully build off of this. And then as far as the techniques that we plan to use, there's also been some great work that's been done by others as well, particularly around the machine learning space in developing techniques and algorithms that can be widely applied and easily implemented by others. So in saying all that, what I really hope to drive home, in order to make progress in our community and with ProPASS, there's a lot of great work being done by individuals across the world, and bringing it together through collaboration is how we can make progress quicker and better and more efficient, as Manos highlighted really well in his presentation. With that in mind, I'd like to give acknowledgments to some of the core collaborators that we've had an opportunity to work with and alongside at ProPASS that has helped make some of our work achievable. First, I'd like to acknowledge Aidan Doherty and some of the work he's done and some of the data he's currently collecting in 160 older adults around the same age as UK Biobank, where they are all wearing wrist, chest, and ankle monitors under free living conditions, with ground truth being obtained from the body camera, ECG on the chest, as well as polysomnography. Also, Joanne McVeigh from Curtin University, who will be having her participants in the RAIN cohort wearing wrist and thigh monitors concurrently in over 1,000 participants, providing population level data that will be usable. Then also finally, Stuart Trost, who has provided data for us that we've used previously for the wrist and thigh concurrently with heart rate under free living conditions. And then also through some of our work, we've also had the chance to come across collaborations with Sharon Gomez-Al, the president-elect for ISPA, and Brownman and Clark, the prior president of ICANN, who provided data for wrist and thigh concurrently in office workers under free living conditions using body-worn cameras. So once again, all the work that we've been able to do and that we hope to continue to do, it's really only been off the help of the collaborative work from the international community. So now going on to the three main sequences of studies that we currently have in progress and then have planned that will hopefully lead us towards the cross-placement harmonization for the ultimate goal of ProPASS to use both wrist and thigh concurrently. So Currently, we're about to wrap up our part one, which has a series of structured and free living activities where we are recruiting 75 participants between the ages of 30 to 75. And for this, they're going to be wearing monitors on both wrists and their right thigh, with our ground truth measures being indirect calorimetry, as well as heart rate. And then during this particular part of the study, we're going to have them complete a variety of different activities where we are having them do it for a preset of time, for a predefined time. This includes gym-based exercises, stair climbing, as well as walking under a variety of different conditions, jogging, and then finally doing a variety of household tasks and chores such as dishes, laundry, and vacuuming. I will say that the staff at our PA clinic that we do these studies in have said lab space has never looked cleaner, and that's attributable to our great participants doing the household tasks. And then once this data is collected and we develop some algorithms and techniques, we then want to validate them under free living conditions and see where there's areas for improvement or refinement. And that leads us to part two, where we'll be collecting data on another 75 participants, same age range, 30 to 75. Similar protocol where monitors on both wrists and their thigh. And this time we'll be getting ground truth measures from body worn cameras, as well as heart rate monitors. And this will allow us to get the free living conditions, activities being done under different domains in a variety of different conditions that we may not be able to truly replicate under the structured laboratory conditions. And then finally, to wrap it all up in part three, we're going to expand this to recruit another 75 participants with the goal of having free living at home sleep measures using at-home polysomnography kit. And this will be done in collaboration with some of our colleagues over at the Royal North Shore Hospital. And this project hasn't begun yet, but we hope to have it starting by the middle of 2024, with plans to complete it by the end of 2024 or early 2025 to ultimately hit that goal that I mentioned at the beginning, to have all the algorithms and techniques incorporated into ActivePass and making all these data sets available for the research community as well as the software. So ultimately, the goal is to bring these data sets together. And when we bring them together, we hope to give meaning to the signal. And then by giving meaning to the signal, we hope to be able to harmonize across the different placements using standardized methods. And then through that, we realize, as Matt pointed out, there's likely going to be some challenges that come up, especially as the wrist has some advantages that the thigh doesn't, and the thigh has some advantages that the wrist doesn't. And how we plan to address these and answer these questions is through, once again, really driving home the point of the international collaboration. The great minds of researchers doing work across the world, bringing together, hopefully, to working together to reaching that ultimate goal. And then in closing, I'd like to give acknowledgement to our funders and the Charles Perkins Mackenzie Wearables Research Hub. And without the support, all the work that we have done and have planned would not be possible. And thank you very much for your time.
Fantastic. Thank you both for two really engaging presentations. I think, unfortunately, we only have time for one question, but I have a great one here. So this one is from Marco. He has done an umbrella systematic review about the validation of wearables. And he found a large number of studies, so about 300 different wearables, but a lot of them were validated using very low quality designs, something often we see, obviously, with systematic reviews. He's suggesting that maybe we need a certificate for wearables to say we have enough robust evidence to suggest that this is a valid tool to use in research. What are your thoughts on that? I was going to pass over to Matthew, but I can, if you want to jump in as well, Manos, then please do.
Yeah, I'll take a first stab at it. So it's a really good question and some great work that's been done. So when it comes to model development, algorithm, and technique to implement, the model is only as good as the data quality, and the data quality is only as good as the team collecting it. So you can have a free living study that collects your data, but if that data isn't being collected under rigorous conditions, under conditions, then the data itself won't be really useful when you're training your models and developing it. So as far as developing criteria that have been collected and stringently, I think that's an area that can be addressed to grow and create some kind of standardized checklist that when researchers want to do development studies, they can make sure they're adhering to it. And by doing that, it might also make the data being collected by different studies, by different people, more easily amenable to bring together. Because if you bring multiple studies together, you're creating a much more richer and powerful data set that can be used to develop these models.
Fantastic. Thank
Yes.
you, Matthew. So
Can I add?
provided evidence around the checklist. Manos, is this something that the Mackenzie Hub would do? Validate or provide a certificate for wearables?
I don't think that the certification is necessary. With considering the pace of introduction of new consumer models in the market, I mean, you have something like about 50 manufacturers, and some of them throw a new model in the market every 6-8 months or 1 year. This is going to be impossible. The key thing to me is ensuring that if epidemiological studies use consumer wearables at scale, that researchers have access to raw data, raw signal. That's the key. The raw signal of all sensors. In the case of accelerometry, as we showed in ProPASS, it's a standard sensor. The cheapest accelerometer, they're dead cheap. I can't remember. I think the actual component is bought from China between $5 and $10, something like that. It's very standardized technology. This is 2007, 2008 technology that hasn't changed. So it's access to the raw data. And then it's a question of whether us, the academic community, have unified standards to process that in a consistent way, so that we all, no matter whether someone uses Garmin's, Fitbits, Apple watches, whatever, if they process in a consistent way, the studies will be pullable. Perhaps that word doesn't exist in English, but I'm sure you know what I mean.
That's fantastic. I'm going to sneak one last one in here because this is from Fiona Ball, who is announcing some breaking good news from the WA unit, is commencing work to review and develop, update global guidance on measurement of physical activity. Now, a question to both. What do you consider is the role of industry in this scientific and technical process, and who is the industry? We're going to have a really succinct answer to this. So if you've got one, that would be fantastic.
Yeah, I have one. It's 5 words. I do not think that the industry will be interested. That's my. It's not a pessimistic view. It comes from. I wouldn't say. I think it will be very hard to engage with the industry without. We will need to show what is there for them. I think it will be hard to engage. I'm not very optimistic. I hope I'm wrong on that.
Did you want to give a last statement on that?
Things that some of the meetings Matt and I have had, he's absolutely correct. When it comes to industry, you'll have to show that there's some kind of benefit for them in the long term. And if that can't be shown, they might be a little bit hesitant. Kind of agree with Mans in that respect.
Fantastic. Thank you. Great question. Great response.